In this section, we will introduce the hub, understanding the flooding characteristics of hub. We will understand or discuss the concept of unicast and broadcast communication. Next, we will go over the difference between half-duplex and full-duplex communication. Going through all the aspects of hub, we will also discuss what are the drawbacks or shortcomings of hub. Next, we will cover what we call as local area networks or LAN. And finally, we will go over the discussion on broadcast domains. Previously, in the previous lessons, we had covered how two PCs or desktops or laptops would communicate. Now, I want to give a disclaimer before I go ahead and continue with the explanations. Sometimes I will be saying PCs, sometimes I'll say desktops, sometimes laptops or desktops or host. These are same terms. I interchangeably use them in a loose manner, right? So they are one and the same. Second part is sometimes I will mention them as PC1 talking to PC2. Sometimes I will say PC1 passing data to it or transferring data. They all intend and mean the same thing. Okay. So having said that disclaimer, and you guys all in the same understanding what exactly it means, let's continue. Now, in the previous lesson, we discussed about two PCs communicating using a single wire. Now, if there's another third PC that comes into picture and the communication needs to happen between these three, right? Let's extend our discussion what we had in the previous lesson to this one. So PC1, if PC2 wants to talk to or need to communicate with PC2, it can have a single wire connected to it. But then next, when PC1 needs to communicate with PC3, and what we can do is take out this end of the wire and plug it into PC3, right? Like this. Okay, but then if PC3 needs to talk to PC2, we can again do a similar exercise, take out this end of the wire or the cable and plug it into PC2. Right? And that will again work for PC3 to PC2. But is this an efficient way? No, right? Because we are constantly juggling. We are just, the whole purpose of putting a wire was to put efficiency into communication. And this way, what we are doing is we are constantly plugging out one end of the cable and plugging into some other PC. This is not efficient. So let's think about how these can be interconnected using a central or single device. And that is what the concept of hub comes into play. A hub can be like this, and then you connect all the PCs, PC1 to this, PC2 to again like this, and PC3 like this. And then think about it that any communication between any two PCs that has to happen will take place via the hub. For example, PC1 wants to send data to PC2. This would how it would happen. And then if PC1 wants to send data to PC3, again via the hub, it will happen. Okay. Moving on to some of the structure, what exactly is hub looks like and behaves. Let's move on to that. So a hub is a device which has multiple RJ45 female connectors. Now here in particular, I've just given a picture of 4 ports, 4 RJ45 connectors, female connectors, but this hub can be in practical or reality have multiple more than 4 ports also. Now each of these RJ45 interfaces or ports as we call them can be can be labeled port 1, port 2, port 3, port 4, and in short I have just labeled them as P1, P2, P3, P4. Okay, and obviously these being the RJ45 female connectors, the cable with the RJ45 male connectors would come in and fit into them. Okay. This is how it will work. Now, This is the most important point about hubs, very critical and the most important point. This is where it works. So any frame that enters into hub, the hub makes a copy of it and floods it to other ports. It doesn't care what is the destination address for the frame. Is a hub is a dumb or a non-intelligent device. Any frame that comes into it, it just blindly makes copies of the frame and floods it to the other ports. So let's picturize this. Enters P1, frame comes into port P1 and the hub makes copies of it and sends it on port P2 and P3. Okay, not sending on port P4 because the PC2 is connected on P3 and PC3 is connected to P2 port. Okay, we will take this in more detail. Let's say if PC1 is sending data to PC2. Okay, now here are the corresponding MAC addresses for PC1 being A, for PC2 being B, and PC3 being C. Now, obviously, a frame is made with the destination address as B because PC2 is the target and the source address SA being A. Okay, PC1 has created a frame with these values. Next, frame is sent out of the NIC card of the PC1. It arrives in the port P1 of the hub. Hub makes copies of these like this. Remember, it has not changed anything of the source address or destination address. It is still the same. It is just made copies of it and it is going to flood it on port P2 and P3 like this. This is how it goes. Okay. So that's what is the flooding characteristics of the hub. Now, what is the result of the hub of doing this? Right. Let us go over this. Right. So this, as you can see, the frame, a copy of the frame has arrived at PC3 and a copy of the same frame has arrived at PC2. Now let's see one at a time how will PC2 react to it and how will PC3 react to it, right? How will they deal with the frame that they have received? Okay. So let us look at PC2 first. What does PC2 do? PC2 checks the destination, the value of the DA field. Okay. It says DA field is B. Okay. Finds it to be B. Checks own MAC address. Okay. And find it also to be B. So it says, oh, the frame was sent to a destination address B and my address is also B. So it matches and that means it is intended for me. It was sent for me. So I should accept it. That is why it accepts it. Okay. Let's look at how does PC3 handle or interpret the frame that it has received. Same logic, same concept. What it does is PC3 also checks the destination address field of the frame. Find it to be what? B. Right? Here also it was B. Here it is B. Right? So it finds it to be B. And then it checks its own MAC address, just C. Okay. Now, does it match? It tries to compare, but they do not match. That means PC3 knows that this frame was not sent for me. It is not intended for me. So it will simply drop or reject it, discard it. Okay. So by this, what is the takeaway here? Right? This is a big drawback of the shortcoming of the hub. Frame was supposed to be going for PC2, but unfortunately, the hub, being a dumb or non-intelligent device, also sent a copy to PC3. Right? Because of that, the PC3 had to send CPU cycles to check if the destination address matched its own address. So, and then discard the frame. Right? Whereas PC2 accepted it. So this is one of the drawbacks of the hub. that it floods it unnecessary to even to the ports where it should not be. But this is how the property of hub is. It just floods it, and this is one of the disadvantages of flooding. Okay. So the key takeaway to summarize again is hub is not an intelligent device. It blindly creates copies of the frame and floods them. Because of the flooding property of hub, frame unnecessarily get forwarded to some PCs that they are not intended for. In the example we just covered, it was intended only for PC2, and PC2, when it received it, accepted it, but because it was not intended for PC3, but because of the flooding property, it still received it and wasted its cycles. So wasting of cycles, and these PCs waste their CPU cycles, as they have to spend CPU cycles for checking the destination address of the frame and discard those that are not intended for them. Okay. Let's move on to the concept of unicast and broadcast. Unicast is one-to-one communication. Any communication that is made to one destination is unicast. Let us take a simple world analogy or draw a parallel of real world, right? Before we create the concept of how unicast works in data networks or computer networks. So let's take an example. You have Jill and Jack, and Jill wants to talk to Jack. So Jill recollects Jack's number is 7223. So then Jill, what she does is puts Jack's number on her mobile and calls him. Right? So this is basically what is a unicast communication. Talking to or sending data to one entity or one person. Right? Data sent to only one entity is known as unicast. So if we apply the same concept on computer networks, PCA wants to send data to PC2. Only one destination is where it is sending. This is what is unicast. The destination address is a defined address for only one person or one PC. This is B. This is called unicast. Okay. Frame sent to a single destination is called unicast. Okay. Let's move on to the concept of broadcast. And just like we had a case study where we took a simple example of unicast, in real world, we'll also take an example of broadcast. Broadcast, one-to-all communication. Communication intended for all the audience, all the computer, all PCs is known as broadcast. Right? Now, how can you understand this concept? With this simple example, I'll elaborate. Television transmission is an example of broadcast communication. There is a satellite in the sky which is constantly sending television, and then there is televisions in houses on the ground, right? So next, this signal data is sent to all, like this. And so satellite is sending signals, and all the TV channels, televisions which are tuned to that channel are receiving it. This is what is known as broadcast. Send to all is known as broadcast. Now let's come back to computer networks and see how the broadcast system works. Send to all, one-to-all communication. So here again, we have a topology, 3 PCs connected through a hub. Okay, PC1 wants to send data to all the PCs, not just to one. Unicast would be sending to only one. Broadcast is to send to everyone. Okay, so it creates a frame. PC1 creates a frame. Now pay attention to the destination address value. It is not for B or C, right? It is a special address. So set the value of DA field to a special address. We will call it all. Okay, again a disclaimer, right? I am building concepts here. That's the reason I'm using simple terminology. In reality, MAC addresses are different, are of particular characteristics. We will come to that soon in after one or two lessons. But for now, just focus on the concepts. So it builds a frame, puts the special address DA equal to all in the destination address field, and then frame goes out of the NIC. And as usual, when it is entering the hub first property that we learned about hub was that it blindly makes copies of the frame and floods it to the other ports. So port P1 it enters, and then hub makes a copy of frame here and here, and then floods it out to port P2 and P3. Okay. And now the frame has reached both PC3 and PC2. Let us again, just like in previous section, interpret or analyze how will these PCs analyze this frame that they have received. Okay. So let us look at PC3. So PC3, I'm sorry, PC2 checks the value of the DA field, finds it to be all, and all is a special address. That means the data is intended for everyone, including PC2. That is the reason it accepts it. Okay. Similarly, PC3 also looks at the destination address field, finds it to be all. And again, all is for everyone, including C. So C, MAC address C is a subset of all. It comes under all. That's why it says, oh, hence it is intended for me also, so I will also accept it. So this is what is known as broadcast communication. Okay, sent to all with a special destination address. Okay, moving on to the concept of unicast. Okay, no, not moving on. Just a summary of unicast and broadcast quickly. A unicast is a frame sent to only one destination. Broadcast is a frame sent to all. Okay. And then hub does not care if the frame it received is unicast or broadcast. It doesn't know what is inside the frame. It just simply makes copy of the frame and floods it. Hub as such is, as I said, mentioned, it has no intelligence. It doesn't look at what is the field. It is just making copies of the frame and blindly making copies of the frame and flooding them out other ports. Okay. Hub is indeed a dumb device. Few more takeaways, if you may appreciate these points. The PC from where the message originates, it is that PC who decides whether it wants to send a unicast or broadcast. We have taken the example of PC1 sending a unicast or PC1 sending a broadcast. So it is always the PC who's responsible for either sending a unicast or a broadcast. Okay. If a PC wants to send a unicast, it will construct a frame and send the frame out of a NIC. After that, once the PC has sent it out of the NIC, it doesn't know what will happen to the frame. Is it directly going to another PC or is it going by a hub? What is going to happen to the frame? It is not aware of that. It is totally out of its control. If the next element is the hub will flood the frame. Okay. The PC from where the message originates is the one that decides whether the message is unicast. I think this is repetitive. Let's just skip this. Okay. The hub simply floods the received frame to other ports. It does not broadcast the frame. Don't get confused. Many people in the industry get confused between flooding and broadcasting. Broadcast is something that a PC does. Okay. Flooding is something that a hub does. A PC never does flooding. Okay. When a frame passes through a hub, the hub being a dumb device, it does not read any part of the frame and it doesn't modify or alter any part of the frame. Okay. Okay, let's move on to the concept of half duplex and full duplex communication. Half duplex. Okay. If we have two PCs, PC1, PC2, the concept is both have the capability. PC1 is capable of sending and transmitting at the same time. And so is the PC2. It has also got the capability of transmitting and receiving at the same time. But the transmission medium does not allow it for both of them to be sending simultaneously. Right? So what this means is both cannot transmit simultaneously. Only one at a time can send. PC1 send it to PC2. Similarly, PC2 can send to PC1. But both cannot send at the same time. This is what is half duplex. And if when both transmit simultaneously, a collision occurs and data gets corrupted. Okay. Full duplex. Same thing. PC1 as well as PC2 have the capability of sending and receiving simultaneously. Simultaneously means at the same time. And this time for full duplex, the media or the mode of operation also allows them to send and receive simultaneously. So they can both will transmit and receive at the same time. Okay, this is what is full duplex communication. Hub is a device that only supports half duplex communication. Okay, that means only one device can transmit and the others cannot transmit at the same time. They can only receive. So when PC1 transmit, PC2 and PC3 will only receive. Right? Again, flooding is happening, but the key concept is the hub does not allow a full duplex communication. Similarly, if PC2 wants to transmit, PC1 and PC3 will only receive like this. And likewise, if PC3 is transmitting, only PC1 and PC2 can only receive. Okay. Now, if by chance PC1 and PC2 transmit simultaneously, then a collision will occur and the data will get lost. So this is another shortcoming of hub. Now, because of this, what happens is, think about it, right? Both the PCs can transmit, all the three PCs can transmit simultaneously, have the capability, but the Ethernet hub or the hub does not allow them to do it. And because of that, because of this, the transmission speed and the throughput gets reduced. And whatever was the available bandwidth, what was the capability of the cable, right? Whatever speed it could support, it is not able to utilize it. Bandwidth is wasted. So this is the second drawback of the hub. Okay. Local area network. So we had our three PCs, PC1, 2 and 3 connected to port P1, P2 and P3 of the hub. So this is, and similarly, now we have another such setup, another hub. We can call this as hub 1 and this is the hub 2. Okay. And this becomes our LAN 1. What I'm going as LAN 1 and this other one can be our LAN 2, local area network 2. And this is what we will be calling broadcast domain. Why do we call this as a broadcast domain? So imagine that PC1 is sending a broadcast. Does it mean? That it is intending that the data that it is sending should be sent to both PC2 as well as PC3 and both should accept it. That's the reason it will use a broadcast address. In this case, we have learned the broadcast address for now in simple terms is all. Okay. So when it sends it, it will be sent to PC2 and PC3 and both will accept it. But it will not, since this is how these are connected, its area of operation, right? The broadcast domain is this much only. And likewise, if in this is a separate LAN, right? Local area network. Okay. With PC 4, 5, and 6 in this, and having their own MAC addresses D, E, and F. And if any of these computers or PCs is sending a broadcast, that means that broadcast will only, so let's say PC6 is sending a broadcast, that will only be accepted by PC4 and PC5. Right? It will not go to PC1, 2, and 3. That is what it is. So this is a separate broadcast domain, and this is what is the separate broadcast domain. Okay. But how about if we combine these together? We connect the one, we take a cable and connect these ports together, two hubs together, cascade them. Then what happens? Then this LAN 1 and LAN 2, which was segregated, separate, no longer become two LANs. They turn into a single LAN. They become a single LAN. Yeah, it has got two hubs in it, but that's okay. They are all connected. Okay. This we can say hub 1, this is hub 2. Okay. And now let's see what would happen if you have to start communicating. PC1 wants to send data. Let us say it wants to send data to uh, all broadcast. So it creates a frame. And then frame goes out of the NIC like this. Frame enters the hub port P1. Remember, what is the property of the hub? When it receives a frame, it blindly makes copies of it and floods at other ports. So in this case, it is supposed to, it has received it on port 1, going to make copies of P2, P3, and P4 and send it. And again, here to keep the matter simple, I am just denoting the frame with using an arrow and not saying DA SA field here, right? Again, okay, so this is where the frame is entered. Next, the hub is going to make copies of the frame, makes copy of the frame, and floods it on those ports, right? And then further, similarly, this is going to repeat at the sub also. When it receives the frame, it receives on the port P1, it will likewise flood it to the other ports of here. And since this is a broadcast intended for all the PCs will check the destination address of the frame, find it to be all, and since they are part of all, they will all accept it. So this is the entire, this becomes a single broadcast domain. Okay. This is a single LAN and a single broadcast domain. Okay. So just putting it in points, this is what it is. Flood these copies out of port P2 and P3. When hub 1 received it, it sent it off P2, P3, and P4. And then frame was reached PC2, PC3, and port P1 off. So frame was received at PC2, PC3, and port P1 of hub 2. This is being hub 2 and this being hub 1. And then hub 2 makes copy when it receives it, copy of the frame, floods these copies to port P2, P3, and P4. Right? I'm just reading out what I already explained. So this is pretty much what it is. Frame reaches PC4, PC5, and P6. In a sense, now when you connect the two hubs together, they converge or shrink from two LANs into a single LAN, and two broadcast domains become a single broadcast domain. Think about it as the broadcast, where exactly the broadcast will go. Will go all these PCs, always accepted. Okay, that is the concept of broadcast. In the next lesson, we will move our discussion to the operation of layer 2 switch. Layer 2 switch and how it overcomes some of the shortcomings of hub. Now, L2 switch, the reason we call it as L2 switch is because it operates at the layer 2 of the OSI model, or the data link layer of the OSI model. And it is going to be an interesting chapter and some more interesting learning coming forward your way.